From AI-powered robots replacing human jobs to machines that might outthink us, the story isn't just exciting, it's a little terrifying. What's really going on behind the scenes of this AI revolution? This has to be one of the most surprising releases of the year so far. And yeah, I get the irony since the year just started. I'm talking about the DeepSeek R1. Have you seen this? DeepSeek R1 has just been announced and it's making waves across the AI community. This model is genuinely impressive because its performance rivals OpenAI's GPT-4. But here's the real shocker. It's not just about performance. What's truly surprising is that DeepSeek R1 is fully open source and available to everyone for free. Yes, you heard that right. Free. You can find it directly on their website, which is a massive deal for the industry. The research behind this model and its effectiveness is nothing short of groundbreaking. It's no wonder the internet is buzzing about it. In fact, this development has even caught OpenAI off guard. It's a clear indicator of how fast the AI landscape is evolving and just how far these models have come in such a short time. Let's dive into why this is such a big deal and what it means for the future of AI. This bar chart here illustrates exactly why the DeepSeek R1 model has been making waves online recently. DeepSeek R1 is a direct competitor to OpenAI's O1 model. Both of these models are built around a concept called System 2 thinking. This approach allows the models to think longer and more strategically, which is a relatively new concept we've only just begun to explore. As you can see from the chart, this method is delivering impressive results across the board for any models developed using it. What's even more surprising is how China has managed to challenge, and in some cases surpass, the traditional leaders in AI innovation. While OpenAI has long been considered the frontrunner, DeepSeek R1 proves to be a strong contender, performing right on par with OpenAI's 0-1 model. In some benchmarks, it even outperforms the smaller version of OpenAI's 0-1 model. Keep in mind, these benchmarks are extremely challenging. Some have error rates of just 2 to 5%, meaning these models are achieving near-perfect accuracy on tasks that were once considered incredibly difficult. It's a testament to just how effective and advanced these systems have become. This raises an important question. If we're already seeing such rapid advancements in AI performance, where will we be in 3 years? The pace of development is accelerating, and it's exciting, but also a bit mind-boggling to imagine the possibilities. What makes DeepSeek R1 even more remarkable is its affordability. Not only is it competitive with OpenAI's 0-1 model in terms of performance, but it's also far cheaper to use. This opens up state-of-the-art AI capabilities to a much broader range of developers, from those building innovative products to those just experimenting with the technology. In short, this could be a game-changer for the industry. AI models have typically been incredibly expensive to develop and run, but with DeepSeek R1, we're entering a new era of accessible and affordable innovation. Let's talk about this part here, which I think is an amazing piece of innovation from the team. A lot of people missed this while everyone was caught up in the R1 versus Undraude Vivadam. But in the research paper, they actually gave us a glimpse of how the distilled models perform. Now, if you're unfamiliar, model distillation is a process where a larger, more powerful teacher model transfers its knowledge into smaller student models. This makes the smaller models more efficient and intelligent. It's done primarily for efficiency. You're essentially packing the expertise of a large model into something smaller, which saves time and resources during inference. Here's the impressive part. Without distillation, we wouldn't be able to achieve similar performance levels in smaller models. Distillation allows us to shrink the model's size without sacrificing much in terms of effectiveness. That's huge. In this paper, we're seeing these frontier models like GPT-4, Claude 3.5, and others performing well on various tests. But what's really exciting is how the new R1 model from DeepSeek is being distilled into smaller versions, like a 70B model, a 32B model, or even an 8B model, and still managing to surpass these larger models in specific scenarios. Just think about it. You're getting the performance of something like Claude 3.5, but in a much smaller, more compact model. That's a game changer for so many people and applications. Of course, it's always a good idea to test these models on your specific benchmarks, whether you're using them for creative writing, solving math problems, scientific reasoning, or coding. You'll want to ensure they meet your particular needs. Some models excel in certain areas but might fall short in others. So, thorough testing is key. What's remarkable here is that we're now capable of developing incredibly efficient models that rival much larger ones in terms of reasoning and performance. And this trend is only going to accelerate. Who knows? In the near future, we might have insanely smart AI models that are smaller, faster, and more accessible. Take GPT-4 as an example. It scores around 70 on certain benchmarks and 50 on tough tests like GPQA. But these distilled models are achieving comparable results at a fraction of the size. That's incredible when you think about the implications for efficiency and accessibility. And this isn't even the only surprising thing mentioned in the paper. There's so much innovation happening here that it's hard not to be excited about what's coming next. One of the most fascinating aspects they discuss is the concept of self-evolution and the emergence of advanced behaviors as the model spends more time computing. Essentially, the longer the model is allowed to think, the better and more refined its responses become. For example, behaviors like reflection, where the model revisits and reassesses its previous steps, and the ability to explore alternative problem-solving approaches arise on their own. What's incredible is that these behaviors aren't directly programmed into the system. Instead, they naturally emerge as the model interacts with its reinforcement learning environment. This spontaneous development significantly improves the model's reasoning skills, allowing it to handle complex tasks more efficiently and accurately. What they're highlighting here is that as the model engages in extended reasoning, it often discovers innovative ways to solve problems, solutions that weren't explicitly taught during training. This kind of emergent behavior demonstrates just how powerful and dynamic these systems can be. Let me show you an example of this in action. Right here, you can see the model working through a math equation. What's fascinating is how it's reasoning through the problem, actually thinking about how to solve it. Now, notice this part they've highlighted. It says, wait, that's it. That's like the model having an aha moment. This is pretty surprising because it shows the model rethinking its approach in a way that feels almost human. Using an anthropomorphic tone, it's as if the AI is reflecting and self-correcting. What's really interesting about this DeepSeek R1 model is that it seems to think in a way that's surprisingly similar to us. It's almost like we're hearing the inner thoughts of an AI as it reasons through problems. And here, it figured out something, paused, and said, wait, I can flag this and solve it better. Let me show you another example of this. It's absolutely mind-blowing. In this clip, a user on Twitter shared their experience of prompting an AI model to think of a random number. What's fascinating is that they also shared the model's internal reasoning process, and it feels surprisingly human. The model starts by acknowledging the task. The user wants me to think of a number between 1 and 10,000 but not tell them. It even notes the instruction to not overthink it and decides to pick quickly. It goes on to consider some options. 777. That's one of my numbers, but maybe it's too obvious. What about 1234? No, that's too sequential. Maybe a number that's common but not predictable, like 42. That's from The Hitchhiker's Guide to the Galaxy. Or maybe 2004. No. How about 18,765? Wait, that's from a song. What's mind-blowing is that we're getting a glimpse into how the model thinks. OpenAI's models have always kept their internal reasoning hidden, but this example gives us a rare peek behind the curtain. It's almost like listening to a person figuring things out aloud. If you enjoy this video, don't forget like and subscribe this channel for more updates. See you in next part.